Okay, so before going to today's class, I'm going to briefly review yesterday's homework. And so it's actually very simple once you know the solution. So the task for this homework is that we want import external file with gene names and gene expressions, and use those gene names and expression to repeat what we have done for the previous homework, that to print out some genes over the threshold and print out the gene of interest. So this is the gene, the file we are going to deal with. So it's a text file with many gene names and different information about those genes. And the last column is about the value. And MATLAB luckily has a built-in function, import data, that can load this file and load this file into a structure, and therefore we can separately extract out the gene names and the gene expression. So if you don't remember, you can search the use of import data and check what's the data for this structure A. And then, so here we directly show the result. So one variable here is a gene name and another is a gene expression. And the last thing is we use these gene names and the expression to search the gene list and find those genes we're interested in to print them out. So now the only thing we need to do actually is one line of code, right? So this line, which it just use the functions we wrote before. So remember, this is the function we wrote before. This function will import the gene names, values, gene of interest, and threshold. Once you provide these arguments for this function, and it will go through this gene list and show those genes over that threshold and the gene of interest, right? And the return output for this function is the expression value for the gene of interest. So this is already a function we have wrote it up. So therefore we can directly use it. So the only thing now is we provide those arguments to these functions. The gene names is the files we load, so that the gene expression, and the gene of interest is provided by the user, and the threshold is also provided by the user. Right? So those arguments will be passed by from this outside function to the inside function. Right? So now we directly use the previous function. And in the end, we need only to call this function without providing this file name, providing the file name, the gene of interest, and the threshold. So if you want to call this function, you just need to type in the command window. I call this function, right? So you will then search, there is a function in the folder, in the current folder, this function, which is right in here. And we need to specify what is the name for this input. So the name will be this text. And remember to add those dot of the format of this file. And gene of interest, I'm not sure which gene is my interest. Let me take random one. And then I will give it any arbitrary threshold I want to have. So now I provided the 3 arguments for this function. Right? I can try to run it. So it gives me a set of results which contain the gene of interest and those genes with their expression over that threshold, right? By loading the file from the text file. So that is how we use function. When we use this function, it will go through, get into this function, load the file, and then call another function which was written before, and then finally export the output. So I have a question. If the file is a different folder, can you just write the folder path in the input? Yes. So if this file, if this experiment1 tags is another folder, you only need to provide the path. Right? Like here, you provide, for example, it's C. You can provide something like this. Provide the path of this file. Then you should be able to locate this file and find this file for your purpose. Okay, so that's all for the yesterday's homework. There is another question. Once I assign the function, could I use it forever even if we open MATLAB? Okay, that is a good question. So once we have wrote some functions, and you probably want to keep it as a kind of built-in function for MATLAB. So therefore, whenever you open MATLAB, you want to also be able to use it, right? So that's, of course, our overall goal to write a function. So in order to achieve that, you need to locate this function, right? So you need to tell MATLAB it can find out this function in this folder, right? So the way to do it then is to go to the home button here, panel, and then you see the set path. Again, you set add a folder for this function, right? This is my current folder, add folder to this default folders that MATLAB will search. So once you add this folder is added. Then next time, whenever you want to call this function, MATLAB will know that I will search this folder to find whether there is a such function. If there is, which is written by you, and then they know there is a function I can use it. So therefore, you will be able to call this function whenever you want to use it. So that's how the way we can package what we wrote in the script as a function, and later for many different users. Okay, let's get back. Is there any more question regarding yesterday? Okay, let me check. Right, if you want to override your previous function, you need to edit the previous functions. Right, so if you want to override this function, then you need to edit it, right? Because MATLAB will only allow the function with the same, only allow one function with the same name, right? So if you want to override it, you just need to write something here to change the function by hand. Okay, so for day 3, oh, sorry, one more question. Oh, okay, so that's all. And for day 3, before going to day 3, let's again briefly review yesterday what we told. One thing is about while loops. If you can remember how we use while, and it is equivalent to use as for loops. And another statement is called break, where we can break out these loops anywhere we want. And we have talked about vectors and high dimensional matrices and how to sort vectors and matrices. And the more complex data structure is a cell, which is a composite of many different kinds of data. And lastly, we talk about how do we define functions and use functions, and how do we import from external files and pass the output. So that's what we have learned so far. So today, since you have learned yesterday how to write functions, today will be relatively easier because we're going to start plotting. So plotting is whenever you have some result, in the end you want to have figures to show the result. Right? That's why we do plotting. And in terms of code, it becomes a bit more easier than those line codes in the function. But I hope that there is some trick I can try to convey to you about those plottings. So first of all, could you open the example 19 in your day 3 folder? If you have opened it, you can run it first, right? It's very simple, only 3 lines of code. Make sure you understand every line. And now change this plot of linear function to be a quadratic function. So here we have a linear function. So it is y equal to x. And here x is from 0 to 100 with a step length 5. So it is a vector. And then y equal to x, you plot xy. So this is the plot function in MATLAB. First give x and then y. And the task is to change to be a quadratic function. You can try this. Remember, this one is the x squared. And you may also try this, x times x. However, if you try this too, probably it won't work. That is because in MATLAB, if you want to do a vector or matrix operation, you need to know which product you are using, right? We introduced 2 products. One is the matrix product, and another is the element-wise product. Let me show you this. We have tried the. Let me share my screen. Right. So could you see my screen on the handwriting? So we have previously introduced, right? So for the matrix product, there are 2 kinds of product. One, it is a linear algebra when you're in the matrix product, which is the first element will be equal to the first row times the first column. Okay, so sorry, let me change to handwriting. Could you see it now? All right, thanks. So the matrix product is what we learned in algebra. It's the first row times the first column be the first element of the result, right? A times A plus B times C. Right? So does for the other elements. And the element-wise product dot times dot multiply, right, is the element-wise, which is A times A be the first element, and then B times B for the second element. Right? So now if we have a vector, we have a vector which is, let's say we only have the AB here, right? It's a vector, and we only have the capital AB here. It's also a vector. And then you do matrix product, it will simply not work because the dimension doesn't match. this is one row vector, this is another one row vector. They cannot do matrix product, but they can do element-wise product, which will give you the first row here, A times A and B times B. So that is the case happening here. X is a row vector, right? So it has one row, 21 columns. You can even click out. So it has one row, 21 columns. This is the X. And if you do X times X, their dimension does not match. So you cannot have this operation. But instead you can do dot star, which is dot times, is element-wise product. Now it just simply multiply every element by element, right? So this one be 0 times 0, 5 times 5, 10 times 10, and so on. So then you will get y equal to x squared. And then plot y equal to x squared. So how do I visualize the x vector? I just double click x in the workspace. Whenever you want to visualize this variable, you just double click the variables here. And another way is to have those power, right? So power is the upper square, but still the power also has a difference between the matrix operation and the element-wise operation. So adding a dot power means we do the element-wise power. Right? So then it is equivalent to x dot star times x. So then now you can write it. You say it gives x squared. So this can be any power. Right? So let's see what it says. So just remember, whenever you have a vector and you want to do like manipulation and power, and you need to add a dot to make it element-wise. Okay, let's get back. So this is a goal for this task. And now could you change the x to be minus 100 to 100? And to say how the plot will change. And then you change the step size to be different numbers to say how do we change the resolution of your figures. So this is not very difficult. The goal here is to help you get a sense of what's the resolution we should have for the step size. Now we have a curve here. It looks very smooth, right? But if we like increase the step size, you see that the curve is not that smooth anymore. Right? You see there are some like strict line, because what MATLAB does is they take this x, and get the y and plot those dots, right? Because x is only discrete values, minus 100, minus 80, and you also have y, right? Corresponding y. These are just discrete values. And then MATLAB does is to make these dots and connect the dots. So if you have the dots very sparse, and then the figures will be also very coarse. So the way to make it smooth is you make the step size small enough. And like 5, you can even make it smaller. 1 becomes smoother and smoother, and even 0.1. Right? So it depends on how many of the dots, how much smooth you want to have your curve to be. But at the same time, if you increase it, makes the resolution very high with small step lengths, then the memory, the size for this vector becomes large and large. Then it may take up of your memory. So you need to have like a intermediate step length where it is give you very smooth curve, but at the same time it's not too big, right, to avoid those explosive memory. Right here you can see that X is already 2,000 dimensional vector. You can even have a million dimensional vector, but then your computer will become slow because it's too big data. Okay, now could you open the example 20? This is to plot a different curve, different type of curves. And you can run it first and change it to be sin x and improve the resolution for this figure. So here I already have a very fine resolution of sin. This is cosine x. In order to change it to sin x, I just need to change sign. Right, so sine and cosine is like the built-in function in MATLAB. You can use it. Oh, okay. So I have the graph. Did you say graph now? I guess not. So this is one thing. Okay, so this is my graph here. Now I already changed it to be sin x and make it with a very high resolution. So, and you can see that we have the x label and y label in sin x and the title, right, in this graph. And they were learned, they were coded by having the x label, y label, and title. And so here, when you add the label, you need to add a single code to tell this is a string. Right? So labels are string, they are not mathematical terms or variables. They're just a string or char. So in order to tell the label it is char, you need to add a single code. Right, so this is how we add x label and y label title. Grade on is just to put those grade of the figures. Right. So that's how we do add something to the figure to make it more informative. And here is a so I have a question. I'm modifying the example in editor. How does it make it happen? I'm not sure I understand the question. So I'm modifying this example in the editor. So, right. So I'm modifying the example in the editor. So the editor has a script. So it is a script, and then you can run this script. After you run this script, it's equivalent to load those code in the command window. Right. So it's equivalent. So basically, script is just a composition of many code in the command window. So when you run it, it just basically goes through line by line. So it's equal to this first, and then this second, and so on. When you click the run. Okay, now in the example 21, could you run this script and plot two curves at the same time and give them names? Curve 1, curve 2. You can try this in example 21.
Can I ask you a question?
Yes.
I'm gonna go ahead and take the attendance. So I'm gonna ask everybody to pay attention to the chat. I'm gonna place a link there, and can everybody fill out that form so that they can be recorded?
Right.
All right, thank you.
So please take some time to fill in the attendance. So by the way, we will have a quiz in the end of today's workshop. So after everything, we'll have a very quick quiz, probably 5 to 10 minutes. Okay, so for this example, sorry, there is some issue in the attendance form. Let me quickly contact Eloy.
So what? Is there an issue?
Yeah, they reported the course name may be different.
Oh, it's
Does it matter?
yeah. Don't worry. Yeah, I'll fix it right now. Sorry, it's I thought that like I said, it makes sure to. Yeah. All right, I'll fix. You can check it out.
You will send a new link, right?
No, I just changed it right now, so it's
Okay, that's all right.
it's live update, so I could just make. Sorry about that.
Okay, so let me quickly go through this example. So right now we only plot two things, right? So this is one is sine x, another is cosine x. And we plot both, right? So here notice that y first was given as sine x, and then we plot it. And then after that, y is let to be cosine x, which is be covered. So it's no longer to be sine x, and it's be covered. But it doesn't matter since we have already plotted the first one. And then we plot the second one, cosine x. And then we give the x label and y label, title, and so on. And here notice that we have a code called hold on. So hold on simply means after you plot the first curve, please just make it there, and then the second curve will be plot on top of that. So if you do not have hold on, the previous curves might be covered. You can try that. So we will have the figure that only with the second curve. And so that's what hold on does. And you can see that we have also the legend here. So legend in MATLAB is give the legend for each curve. So it will assign the name one by one to what you plot. You plot this one first, so it will assign the name curve one to the first line you plotted. And it will assign the second name to the second line you plotted. The third line hasn't been plotted, so it will not assign to any line. So you basically show that's curve one and curve two. Right? So if you want to adjust the proper name, right? So you need to change the name to be like sine and cosine. So then run it. You will see a figure like this. You see sine curve and cosine curve. Whatever you put for the legend, you can put any legend you want. Oh, sorry, this figure sharing is. Okay, so that's for this example. So the only thing here we need to pay attention is this hold on. Whenever you want to plot multiple lines, use hold on to plot them together. Right, so you can also plot even more lines. Could you add another line in this figure, which is at the third curve, which is 2 times cosine x, right? And then rename them. So ideally, you should get a figure like this. Just the practice to be more familiar. So if you have finished, you can open example 22. And you can run it first. And then the goal for this script is to change the scope for this x and y axis. When you change the scope, then we want to show all the figures, rather than part of figures. So first of all, we run it, and what we'll say is this figure. Right? So this figure is just to show a part of the curves, sine x. It doesn't show the whole of the figure we want to see. So in order to change that, one way is to have the axis. The axis has 4 numbers here. The first number is the left limit of x. Second is the right limit of x. And third is the lower limit of y and then upper limit of y. In order to change that, we notice that x has from 0 to 10, right? So here it's from 0 to 10. It's already the scope we want. But y might be too small. So we wanted to change the lower y to be larger and upper y to be, lower y to be smaller and upper y to be larger. And then we see how it looks. So it would now look like this. You see that x is from 0 to 10, y is from -2 to 2. So you can now, with different zoom on these figures. And an equivalent way to do this is you can separately change the x limit, right, like this, and the y limit, and like this. It is the same as axis, right? It's just separately assign the limit for x and y, right? Because sometimes you don't want x limit. You want it to be arbitrary, depending on what data you have. And if you only want to have the y, you can have only y here. So now you can see the figure. So that's a figure. Wait. Okay, so that's how we change the zoom size for visualize the figures. And then another first task for this script is we want change its visualization. Okay? So we want to change the font size for this figure, like the sin x, cosine x, and those numbers, right? We want change it to be bigger, for example. And another thing is we want to change the line width. Just that is the how wide this line is. We want to make it more broad, or more thin, depending on your preference. Please try to change them and to see how they will give you different views on the figures. Okay, so hopefully you have played with it. And here I want to say something about those adjustments. First, we can change the line width, right? So how broad this line is. We can change it to be 2, or the default should be 1.5 or 1. Right? So the line might be too thin to see if you have a big figure. I can make it very, very thick. And probably you can see my figure, now it becomes very thick. So because that's what we change the line width to be very big. And we can also change the color. Here, G means green. And there are some popular used colors like R means red, K means black, and B means blue. And those line style, two slash is like the two is like the dash line, and if one it is a solid line. If it is this way, it's a dotted line. And so there are some line styles in MATLAB we can change. For example, here we can see how it looks. Now we have a blue line. So it totally depends on your preference, what color you want for your figures. And then the second thing is, so all of these options, you can search them by search the plot. You type plot, and you will see this window, right? And this is a long documentation, but you can just drag it down, and there is some documentation about the line style. This is solid line, dash line, right, dotted line, and different symbol, right, circles, star, square, and different colors. R is red, G is green, and more colors. Right, so the colors, there are many different colors you can choose. So that's the styles about these figures you can adjust. And the second thing is the font size. A very straightforward way to do this, change this font size, is you give a code, a line of code called set GCA, then font size with single quote, and give a number. This number is the font size. So GCA basically means I will get all the font size for this figure. Right? GCA is like a global change of all the font size in the figure. All the numbers and words in these figures will be changed by their font size. And then font size you can give any. I can give it like 40, right? So you will see that the font becomes very big. Right? Like this one, it's very big. But sometimes it's might be better if you have those small panels in your figures. And the second thing is you can individually change the font size of, for example, like the legend. If I have a legend, I can individually change the font size of legend by having defined first the legend as a variable h, and then set h font size to be a different one. I can set h font size to be very small. Right, so, and then we can see the figures. You see the font size for h is very small. The other font size is very big. Right, whatever you want to change for your figures, you can add some line of code here to change the style and font size. Okay, so let's get back. Any question about this example? All right, so next one is about the subplot. And sometimes we want to plot several panels for a big figure. And MATLAB has a function to do that is called a subplot. Could you open the example 23 and just run it to see what it gives? And then probably there is some task there in the code. Right, the task is add a third plot with tangent x, add a legend and set the axis. Yeah, I will explain how the subplot works and what does those numbers in subplot mean. So have you already finished? If you have, please you can say it in the chat room. Okay, so here we just want to plot a third panel. Right, so let's first run it. We will have the figures, 2 panel. Right, so this is the figure we got. And to make a third panel, we need to have another subplot. Right? So basically, we can simply copy the other panels first. Right, and now we need to change, what we need to change is the style of subplot. So subplot, the first number means how many rows you have in your panels for the panels. If it is 1, it only has 1 row of panels. If it is 2, then 2 row of panels. The second is the column of your panels. So if you have 2 times 2, 2 by 2, right? So 2 by 2, all the subplot should be 2 by 2. 2 by 2, then has 4 panels, 2 rows, 2 columns. And then the third number is which subpanels you have. So it will count from row by row. So this is the first row, first column. First row, second column. And then second row, first column. So this is how subplot works. We can first see the style of the subplot. So you can see that I now got a figure with 4 panels, but then first one, second one, third one. So once you have that, you can adjust each panel individually, right? So here we need to make it to be tangent to x. We can make G to be tangent to x. Plot G with this line and add a legend, right? And give the y to be -6 to 6. So this is all the requirement we need to do here. And you should save those kind of figures if you do those adjustment. Right, so that's then you can control each panel. Right? So the only thing here is you learn how to use subplot to have multiple panels. But I would mention that in practice, subplot is a bit hard to use because every time you use subplot, you need eventually it turns out to have these small panels, and every panel has the same size, but sometimes your figures have different size for the panels. So I would recommend to plot each figure individually and then put them in like PPT and Illustrator to change each panel manually. So plot figure individually and then compose the figures by using other software. Okay, so this is subplot. And if I have the subplot to be 1 row, 3 columns, I will have those three columns of panels. Another thing you might have noticed is that in the legend we have code named like north, outside, north, outside, north, outside. So this is just to give the location for the legend we have. So we have the north, outside. You can see that all the legends are north and outside of the figure. So that this is what north, outside mean. And so north, outside, you can also use different position. You can change it to be south and anything you want. And the commonly used way is called best. So best or best outside. So by having this, MATLAB will automatically adjust, right, this way. So you have the best here, so then it will search where it will put this legend such that it cover your lines as less as possible to find the best possible position to do not have those overlaps. And you have best outside, you will choose outside position that less cover your figure. So this is whenever you do not know, sometimes you plot very complex figures, different lines, you don't know where the lines will lie. So then you will just have the best to make the legend to be the best possible position you can have. So I have some questions here. Right. So you already have answered. So GCF is changing the background, and the GCA is all about the like font size, the real thing you plotted on the figures. So now we're going to have another style of plot called bar graphs. Could you open the example 24? So one task is to make the bar width with 0.5 width. And another task is to plot a red line with the mean values of those bars on top of the bar graph. I didn't say anything, just to give you some time to do that. If you find it hard to do bar, you can search bar in the documentation. And so this is the documentation for bar. It has many options and how where the variables we should put in, right? So a lot of things to read. But the only thing we currently have is the width. You want to change the width. So it's not very difficult. So basically, you need to have change the width, the second argument of this function to be 0.5, and you can run it, and you see the bar has width 0.5. So that's how we change the bar width. And besides, we want to plot a line of this mean value for this data. Right? So how would we do that? So the first thing we need to give it what is the x-axis. Right? So we want to put a line plot. We should give it x and y. So x should be, let's say, from 0 to 5. So then with a bit smaller step length, and then y should be the same size of x. Otherwise, it will not make a xy plot. So how do we make a same size of x with the mean value of the data? So first of all, I want to have a vector which has all the elements to be 1 and the same size with x, right? So what I can have is I want to have 1 times the length of x size, right? So now I have x, y. X will be equal to 0 to 5, and y is the same size with x, but has all the values to be 1. And the last thing we need to do is to make this 1 times the mean value for this data. So to have the mean value for the data. I think there is a mean function for the data. Yes, so the mean is a built-in function to take the average of a vector. So by this way, you have x, y now, and you can plot x, y with the red line. So I also remember to have a hold down here. Therefore, they should be plotted on the same plot. And now you set arrow. Why it is arrow? Some of them have a, oh sorry, I have a lens here. Let me change that and see whether I have an arrow. Okay, so I will still be able to have it, but yeah. So anyway, so because previously I already have x, y here, they are different size, and luckily they already cover the x, y to be a new size, so I don't have another arrow here. But now you see the result for this plot is like this, right? So you have all the bars, and you have mean, which is the mean value for these bars, and on top of it, this is a line we have. So that's how we add a line to this bar graph. Any question? So here we previously actually used a different way of plotting this line. So it basically have two point for the x and 2 point for the y. So you will connect this point, 0 at the average, and x equal to 5, y equal to average, connect these 2 points as a line. Right? So this way has very coarse resolution, only 2 points, but it is sufficient to have an average. And remember to have hold down here. Okay, now could you open the example 26? Oh, sorry, I got the questions. Okay, so Oh, so some of you said that we should use dot star, right? So this is a good question. So we just have this y times once this vector, right? We use star here instead of dot. However, even we use star here, it is okay because here it is a vector times a value, right? So it is not vector times a vector or matrix times a matrix. It is a vector times a value. So it doesn't matter whether it's a conventional manipulation or it's just element wise. We can add star. It will also work, right? So it will work. If it is a value, it doesn't matter whether this is a star or a dot star. And why can't we do y equal to mean data? Okay, if we have y equal to mean data, then y will only be one value. Right? So y will be one value. And then what is x? X is a vector. So now we can try that. Sorry. So y is so you say that there is no line here, right? Because y is only one value, so it should have one point here. So only plot the x and y with this y as a point. So you see the figure now does not have a line because y is only a value. So it only actually plot one point on the figure. So whenever you plot the line plots, you need to have x, y to be the same dimensional, variable. Otherwise, it will not be able to plot the line. Okay, let's get to the next example. Could you open the example 26? So this is also a histogram plot, but we generate the data and then plot it. I guess this one is simple, but just take a look first. $26, not 25. I put a task here, but it's you can add the title to this figure, but I guess it should be easy because we see this before. Right, so this example is just to say MATLAB has some functions that can generate some random numbers. And so this norm rand is a function that can give you a sample from normal distribution with the mean to be first value and the variance to be the second value, and generate it as an array or a vector. So this is a 1,000 times 1 dimensional vector, and the second is 1,000 times 1 dimensional vector with different mean from the first one. So this function will generate a random sample from the normal distribution. And now could you open the example 27 to plot these two distributions of the same figure? And you can change the bin size, so therefore they will be look differently. So when you run it, you will see this figure. And so 2 sample from the normal distribution, experiment 1 and experiment 2, 2 samples. Okay, a question is why don't we use the hold on here? Because here we only have plot 1 figure, right? So even if we plot 2 things, but it is actually plotted by one code, so it will be regarded as plotting only once. So we don't only need to hold on here. If you add another plot, another case, right? So you will plot. You need hold on to make it plot together. And if you change it to be 100, and then it will you can see the figures. So the figures will be with more finer bins. So the goal for this this example is to say that when you plot a histogram, it is important to choose proper bins. So if you choose too finer bins, it may make the data have different shape, right? So even if you sample from a normal distribution, you can see that probably the distribution will not look like normal anymore. It may look like have multiple peaks. If I have like even more bins, and let's see how the data will look like. So you will see, sorry, you will see this kind of figures, right? So these figures will becomes even you see some peaks here, right? So it totally makes the figures less smooth and even disrupt the shape of the distribution. So it is important to keep in mind how many samples you have, and therefore to design the number of bins based on your sample size. Okay, let's get back to any question so far? Okay, now we're going to study another thing, is to use some online package. I think this is another techniques we need to master because most of the time we need some external package. So what we need to import is called a violin plot. Right? So this will plot a violin distribution for your data. And if you have internet, you can Google MathWork Central Violin or MATLAB Central Violin to find this web page. So have you found this web page? Great. So MATLAB has many packages written up by other users. So they are providing those packages online, and most of the time it's free, and you just need to download them. So typically you have get into the website like this. Right? So you will show an overview for this function. So basically explains what does this function do, and if you click the functions here, it will show what kind of MATLAB function it has. So it only has one script, and this is MATLAB script, and has the script, all the script here. So then if you want to use it, you can download. Could you click the download, then it should pump up a link, and then you can download. Probably it need you to log into MathWorks, right? Then if you have an account, you can just quickly register one. After that, you should be able to download. And it's better to save this file into your current folder, right? Because we will soon use it. Does any of you have problem on downloading this file? Does everyone get the file downloaded? After downloading, you need to unzip and drag the script file into your current folder. Does anyone have the file already in your current folder? You should be able to see a violin file here, and it's in your current folder. If you need my help to download this file, you can just let me know. Okay, so once we have the file, then you can directly run the script, example 28, to see whether it gives you a violin plot. You should see a plot like this. Right, so this is a violin plot by those package, right? But that package is essentially a function, right? By some people, and they will just plot the two random generated sample as a distribution and plot their mean and median. And so that's all the script that function does. And hopefully by this, you can already know how you need to download those packages. So then, in your future uses, most of the time, you just need to download some package for your purpose. Find the best package, and then read the instructions and use them. And so this is a package we downloaded and put in the current folder. Make sure you put in the right folder you are, otherwise you cannot locate this file. Then plot it. So we'll have a violin distribution. And another package is called distribution plot. And this similarly plot the violin distribution, but has more options to adjust the plot. Could you also download this package? And so while you are downloading this package, we can have a short break, about 5 minutes, and we resume later. If you have any question, just ask now. Okay, I will come back in 5 minutes and answer the questions. Okay, so I'm going to answer one question. Is it possible to use MATLAB error bar? Yes. So error bars, I think one way to do that is to have like, there is a plot called arrow bar. But this way you have x. X is the mean value of, let's say, you have x and you have the y, right? And you have the error bar, which is a variance for each data, right? So let's say you have several time points, x equal to 1 to 10, y is a matrix because every time point you will have a set of data, right? Therefore, then you can get error bar at each time point. So the y is like has a we have a random matrix with let's say 10 by 10. So then the error bar is plot the x and the mean value for the y at each time point. Right? So it should be mean value summed by the row, right? And then the variance, the standard deviation summed by the row. Right? I'm not sure whether I make this correct, but we can see how it goes. Oh, sorry, I didn't have figures here. Okay, so we say a plot like this, right? So you have 10 x values and 10 y mean values to plot as a line, and each value has a certain error bar based on the measurement at each time point, right? So MATLAB can has this error bar by using the function called error bar. It's same as plot, but besides of x, y, it has a same dimensional vector giving the standard deviation, right? So once you have, of course, you need to have the data to allow to have your error bar, right? If you have only single data at each time point, it will not have error bar. But once you have multiple measurements at each time point, you can use this mean and standard deviation to add error bars. Okay, so are there any other questions? Okay, and then distribution plot. We hopefully have downloaded the distribution plot right online. This is a package, and then you can open example 29. Right, so just use the distribution plot. Here I have already the distribution plot downloaded in my current folder, and I just need to plot it. And why do I insert the distribution plot like this? Because I read the documentation here, right? So the documentation is sometimes it's a bit long, but it will tell what are the options you can adjust for the figures. Right? I read the instructions, and it turns out I can adjust several options like what is the histogram orientation, what is the color, what is the width of the division, and whether it's showing some mean or median, right? So these are all the options in this package, and we have to follow the instruction and to say, okay, sorry, this one. Oh, so it says that my error bar is not found. So it's probably that when I download this function, I haven't downloaded its another function in this package, right? So probably it will not be able to do this my error bar. So this one is not in the current folder. So this happens if you lack some functions. Let's try another one. Okay, so this one works because it doesn't have many options as I use a distribution plot, right? So here, after inserting the options, it might need the error bar function, but which I haven't put in my current folder. So the solution to that is that I need to search this function online to say, okay, where I can find this function and put in the current folder, and then it will help fix this problem. Okay, so that's the usage of distribution plot. If you encounter the same problem, you can try just to add this function to the folder. It will, I'm sure it will solve the problem. Is here now. I don't want to spend more time to search this function. Okay, and next example is called random per. So random permutation is just a random permuted the sampling data you have, right? So you can read the documentation for the random per. Oh, by the way, if you another way to open the documentation is to have the help and then type the function name. This is the same as you type this function in the upper panel of the MATLAB. So then you can read how the function was used. It will return a row vector containing k unique integers from 1 to n. Right, so if you have random per 6, 3, it will give you 3 examples from 1 to 6, which probably is these values or different values. And you can open example 30 and trying to run this to see what result you can have. To run this, you also need another function called plot spread. I guess this function is what's in the distribution plot you previously have downloaded. Right, so you see so here you see the distribution plot, right? So it has another function called plot spread, right? Indeed, we saw there is my error bar, another function here, right? So that's the function I was previously missed. If I download them and put in the current folder, it will solve the previous problem. And now you need to have the plot spread in your current folder. Plot spread, and then you can run it to see what this plot spread gives to you. You see in the previous, we first randomly generated sampled 1,000 times 1 vector from a normal distribution, right? Sampled 2 normal distribution. And now I randomly generate 10 samples from those sample distribution. Right? So I use random pair to take 10 values from 1 to 1,000, arbitrary 10 values. And so now these variables R and D IDX is this RND IDX is only a 10-dimensional vector with 10 values. Right? So then you can use the EXP1, which is a 1,000-dimensional vector to have a small bracket and take the values of those positions. So I would take the 568 position element of this big vector, and so on and so forth. Right? So take those 10 positions element of this big 100-dimensional vector. So then I get 2 subsamples. And I use plot spread to show this 2 subsamples. You can see that that is the 2 subsamples I get. First one has 10 values, the second has another 10 values. So this example is just to help you know how you would subsample from your data. To use a random permutation to get a sample index, and then take those index of the big original data. Are there any questions? Okay, one question. So this figure, one question is about what does this figure used for? Okay, so figure is to tell MATLAB explicitly that we will open a figure. If I type figure, it will open a black figure. And after you type a figure, all the things afterwards will be printed on that figure. Right? Plot spread is like a plot, right? It plots something on the figure. So figure will tell it will open a black figure. So if I have another figure here, then all the things afterwards will be plotted in a different figure. Right? So this figure is to tell when I want to have one figure now. And everything now will be plotted on that figure. If I have different figures, just use figure again. So actually there is a task is to plot the average values on top of this subsample. I guess it's very similar to the previous one, right? Previously, we also plotted the mean value for the bars. This is same. You just need to get the mean value for this subsample, and then you plot the x and y, right? So to get the mean values. So here is the result. So this is 10 data points, and this is the mean value. It's the same as we did before. Okay, let's get back. Is there any more questions? Okay, another question. Can we compare the means and the p-value? Yes, I think you can add p-value, but first you need to calculate the p-value, right, for these statistics. I don't remember the default built-in function in MATLAB to calculate the p-value, but I think there should be some package you can download it to calculate the p-value. And once you have that, you can plot them, right? So I haven't done this for this example, yeah, but I guess you can try to find a package online. So probably the last example is to have a 3-dimensional plot. We have just plot the lines, the bars, right? So now we're going to plot a 3-dimensional surface. And could you open the example 25? You can run it first and to see what it gives to you. So if you run the code, you will see like surface like this. Right? So this is a three-dimensional surface. And the way the code plotted is it first need to generate a mesh grid, right? So like the XY two-dimensional grid. And then for each point on the grid, you will have a Z value. So this would be a three-dimensional plot. So MATLAB has a function called mesh grid to generate a square, two-dimensional square. And the mesh grid will give the XY values. So X will be from -2 to 2 with step length 0.1. So does Y. So this will be a square grid. And for each of the values, you give it a Z value. Each of the point on the grid, you give it a Z value. And remember now here, X, Y are matrix now. So whatever you use the function to do, you do like power, you have to use dot, right? So otherwise it won't work. You have to use dot to do it like element wise. So once you have this one, then you basically assign every value to a grid and to have this function. And you can use a plot function called surface, right? So it's a surface and give X, Y, Z. And it will show the three-dimensional plot we have just seen. And I also want to introduce some tricks to adjust this three-dimensional figure. For example, you can adjust the angle of view these figures. For example, you can use a view 2. This is a like default of change the angle of the view 2. Just use a default value for to visualize the figure from the top. And we can try this. You will see this one. You will see this figure. So we are visual from the top to the bottom, right? So this way you can adjust the view angle. You can also adjust like the whether there is lines, there is contour lines on this surface, right? So if I do this, I will see this one. And so there is no longer those contour lines as before. There is no contour lines, right? Or mesh grid lines on this figures. So the way to do that is you call shading. So the shading means those mesh lines to interp basically means interpret. So just to make it does not have shading. And there are many different style of shadings you can search. And another thing is you can add color bar. And so to show what's the value for these colors, right? If I run this, I will see color bar here to show what's the value for these colors. And then the last thing is we can have the different color map. Color map is like the color code for those colors you assign for each value. And with MATLAB has several different color code. Right? If I use a color code called jet, it will give me this color code. So higher value will be red and no value will be blue. Then it is your choice, up to you to choose what kind of color code. If you want more color code, you can search MATLAB color map. Right, so let me show you. This is MATLAB color map, and on the bottom, there are several color maps, like jet, HSV, hot, right? So these are color maps that was built in MATLAB. You can directly use those color maps depending on what you want to show. Right? If you want to have higher contrast, you probably use jet for all the values. They won't have similar color. Right? If you want to have a very like only high or low, and you probably use those guys. Right? They have a not very contrast change across color. So it depends on your preference now. You have the only thing you need to change is to change the color map here. Now I use jet, I can change to HSV. Now it will have a different color. So all the things now you can play with for this 3D plot. It will give you very beautiful figures on like this color maps. Right. One final thing I want to mention is you can also adjust the figure's size and position by using this. Instead of only have a figure, you can have a position. Right. Tell what is a figure's position and size. So the first number is what is a figure's x size on your screen, right? So if it is minus, it will be out of screen, right? And the second is the height of the figure on your screen, where the figure is. And the third number is the width of the figure. The third is the horizontal, is the height of this figure. And if I have a 1020, it will be a very wide figure. Right, as we can see here, it will be this figure. So I have a 3 times wider than the height. Right. So this is the how we can adjust the figure size and where we want it to show on the screen. Right, so all the things you can adjust in MATLAB, and it basically depends on your preference. And these are things I have talked about: change angle and shading, color bar, color code. And the final thing I want to mention is that everything we have just done in the code, you can do it in this window by manually changing it. So if we go to the figure, let's have a plot a figure. Any figure I plotted. If I go to this figure, right, I can then change a lot of things on this directly on this window, right? So you can click the rotate 3D, and then you drag the figure. You can see that you can arbitrarily rotate, right? So you can rotate these figures, and you can also add zoom in, right? So zoom in. Sometimes there's a visualization. That is because here we don't have a finer resolution on this grid, right? So it shows nothing. So you can zoom out. And you can add some other lines. You can insert different labels, arrows, and anything you want to. So basically, anything we did in the script can be directly done here. So if you are lazy doing script to search for this code, you can directly edit the figure here. I think that's one advantage for MATLAB, because you can directly handle those figures. All right. Are there any questions before we go? So we already finished all the real instructions for this workshop. If you have any questions, you can ask now. Okay, I have one question. If I want to apply that movement that I made in the finger window, how do I extract the setup? That's a bit tricky. I haven't done this. I don't think I suspect it's not doable because it's probably doable, but I haven't tried that. Yeah, you can try to search whether there is a like save option in the failure window to save those comments. But the tricky part is that I don't know whether it will save the treatment you did as a code. So it probably will not tell you what are the code to do that. Right, so I haven't tried that. So any other questions? Okay, so the last part is I will introduce a real example of dealing with a question by using MATLAB, how to transform a real problem into a coding problem, and then solve it by MATLAB, right? So you will see that all the techniques we need are really told in this workshop, and even you can already start to solve those problems. And after this problem, this can be maybe around 15 minutes or less. And then after till that, we end this course and we will have 10 minutes to take the quiz. So that's the rest of the time. Sorry. So the problem is that we want to predict stock price, right? So you see that every day we have this stock price rising and going down. So we want to say whether we can predict that, right? So, and the reason we think it is predictable is that there are people, smart people in this company called Renaissance Technology. So they have made money by applying models to the stock price and predict the stock price. Right? So they are successful, and they are the founders are mathematicians. So they earn money by building models to predict the stock price. So this makes us have hope to build up a model and predict the stock price. So one model that is used by this company is called the hidden Markov model. Right? So I'm not sure whether someone heard about this model, but basically it's a one mathematical model that can describe whether the stock market is have bull or is bear, right? And they can have some transition probability to jump between these two states or stay in these states, right? So if every day nowadays we have virus, then probably everybody has very low mood, then it will probably be like in the bear mood. Right? Then it has some probability to transition back into bull mood. And so then the stock price is dependent on the transition. And when you have different mood, in the stock price will be likely, for example, have bull mood, in the stock price will likely to get high. And if you have the bear mood, it will be likely to get to the low value. And if we have this model learned by the stock price, we learn those transition probabilities, and we might be able to predict in the future how the stock price will likely get higher or lower. Sorry, my throat is sorry. So now, so this is like the predict model. We have a switching between bull and bear. And in the bull mood, the stock price is likely to get lower and to get higher, and then in the bear mood is likely to get lower. Right? So that's how the model predicts. So in order to apply this model and train the model by the data and then predict the future data, the first thing we need to do is to download the stock price data, right? The whole historical data from online. So one thing we can do is I search and I find there is a package called this Yahoo Finance Data Downloader. So this package will automatically extract the data, the current data up to today of the stock price. Right? So you can, then I read those instructions, I use this package to download data from online. Right? You can also do that. This is simple. This is exactly the same as we download the violin plot package, right? Exactly the same. And then you just need to read the documentation to see how it use some shortcodes to use this package to download data, whether it's in the units of USD and what is the date you want to download, right? Just read it, and you can use a package to download data. So this is my code of the downloading the data, right? Just use this package. This is a package function from the package, and I want to download from some time, and what's the data I want to download. Right? And for example, also care about the stock called NVIDIA or Apple, Google. So these are the data I downloaded from online. So once we have the data, next thing is to train the model, and then use the model to predict. So the model used as we have introduced is called Hatermark model. Then to train the model, again, first of all, I just trying to find whether there is already established package to help me do that. So I searched online, and I found there is a package. Actually, it's already built-in function in MATLAB, right? So it's Hatermark model, and it has many instructions to tell you how to use this model. You should initiate those transition probabilities, right? Those transition from bool to beer state, initiate this transition probability. And then given the data, right? After given the data, you will automatically revise this transition probability in order to reproduce this previous historical data, right? To find the most likely transition probability to produce the data. So that's the code I did. Very simple. You just give it the initial transition matrix, and you use this package, input the data. Right? I name it as 6, but it doesn't matter. I use the data with different time lengths, different stock, right? And then predict this, and then produce a model. Right? So this is very simple. And then after we train the model, we can use that to say, okay, whether it can learn the data. So this is Apple stock price. I use the 30 days of data points, and the red, the black are the data, are the real data, right? So I train this data by using this time window of the historical data. This green time window. You can see that these red curves are the model reproduction of the data. Right? You see that model can learn the data very well, right? Reproduce very well. But then in the end, when I want to make a prediction, it doesn't make a good prediction. Right? So you see the data next day gets lower, stock price gets lower, and I predict to get higher. Right? So the model can learn the historic data, but it doesn't learn to predict correctly the future of the stock price. Right? So this is kind of disappointing. And I repeat this for different stock and basically plot some correlation to say whether it's correctly or it's wrong. But there is less stock that is correctly predicted than the wrongly predicted stocks, right? So then it is very disappointing why this model doesn't work, but why does a company make money out of the model, right? So then if we read a bit more about this company has recently have applied a patent that they can finish trading in 1/billion second. So which is here in the data I used every day, right? So the data from every day. So every day we have how many seconds? I don't know how much second we have in one day. So So the resolution of the data is very coarse. Compared with this company, they can have the data for 1/billion second. And with that data, they can have quickly run this model and predict very fast what's the next second the stock price might get higher or lower, right? But from my data, I can only predict the next day. So it's much less lower resolution than the company can have, right? So this is because the data resolution is too low. So this is kind of the same problem we have when we do the plotting. We can specify step lengths. Once we have short step lengths, we will have very high resolution of the curves, very smooth curves. But if we step size too long, it gives very coarse curves. So that's some basic ideas. So already from the data we have, we cannot beat the company, right? So you see that all the machine learning models or using other models will have such problem. First of all, the data is already much worse than those big company has, right? So I guess based on this fact, I would say personal trading is hard to beat over the company. So if you want to investigate a stock, please consider twice, right? Think twice, because you can never beat those companies with such high resolution of data, right? So that's the lesson from doing this real problem, right? And all the techniques I used is what I have told you. Basically, you can also do this. If you have smarter models, you can also try to apply that. So, and the last thing is stock is hard to predict, but I also found the knowledge synchroning process can be predict better than the stock price. So you see here is the data of the one of the biological genes, right? Single cell genes. So each line, each row is a single cell's data, and you have a different single cells with these genes under different drug, right? This is different drug. And you see that this model can reproduce this data with similar patterns, right? So this model can reproduce this data from biology relatively well. But in order to predict the stock, I think you need finer resolution of data and better model. Right? So that's the things we can actually do to solve the real problems by using MATLAB. Okay, so that's concludes this workshop. I guess it's a lot to say more, and if you want to study more about MATLAB, you can do this. Go to this website and to learn more about MATLAB. And now it's quiz time. I will send you a link. And you should be able to receive a link soon by the email. Or actually, I can copy the link in the chat room. Did you receive? Sorry, did you receive the? So in the chat room, there is a link. Could you open? Could you open? If you can open the link, please let me know in the chat room, because my current internet access is not so good. Okay, so if some of you can, it's good. Okay, great, thanks. So now you have, let's say you have 10 minutes to finish this quiz. So it's not very difficult because 6 questions we have already covered in the beginning. And there are 10 questions in total. If you finish it, you can feel free to leave. After 10 minutes, I can spend some time to explain this quiz if you want to, you have something unclear. And I want to thank you for participating in this workshop. I still have 15 responses, which means some of you are still working on it. So we will take another 5 minutes. Okay, do you need more time? Is there some student need more time? If you need more time, you please tell in the chat room. Okay. What I can say now is I have 16 response now. Unfortunately, none of them get 10 points. The average is 7 points.